Assalamualaikum and hi everyone. I am Fatima binti Yusof, lecturer in biomedical engineering, specialised in diagnostic, and I am a supervisor for this group.
Hi, I am Nur Syahada binti member in this group.
Hi, I'm Nur Fatia binti Muhammad Tamis. I'm a partner in this group. We are from KKTM LEDANG.
Hi and good morning. Our group going to present about Final Year Project, which is development of health monitoring system for coma patient via IoT. This is the contents that we go through.
Okay, next we go through the problem statement. We have a 3 point of problem statement, which is number 1, coma patient incapable of manage themselves. Number 2, not available system which is reduce the risk of death. Number 3, medical personnel doctor or nurse inability to monitor the patient every time.
This is objective of project, which is to measure the temperature for coma patients. Second, to measure the pulse rate and SpO2 for coma patient. And last one is to detect the existence of urine for coma patient.
The hardware we focus on just two is design of system head monitor and urine container. The project design and hardware, we use the SolidWorks to design our head monitoring system, and then we use the material of acrylic. This is urine container and head monitoring system, the final look. Next, this is expected of development project, the placement urine container under the patient coma bed. For the system head monitor must be near the coma patient because that our system is wearable direct to patient.
Okay, now we will present our result and analysis for each sensor that involved in this project. The first one is an identify temperature sensor. The validated device that we use for LM35 temperature sensor is infrared forehead thermometer. The procedure: Step 1. We have set up the material for measurement, which is infrared thermometer and LM35 temperature sensor. Step 2. We start to test the validation temperature value for student 1 using infrared forehead thermometer. This is as actual value. Step 3. Record the reading of actual value for student 1. Step 4. Test the measurement temperature value for student 1 using LM35. This is as the measure value. Step 5. Record the reading of measure value for student 1. Step 6. Repeat step 2 until step 5 by change the different students, which is student 1 until student 5. Step 7. Calculate the percentage error between data for actual value and measure value using the formula, which is percentage error is equal to measure value minus the actual value divided by actual value and times 100%. We collect data for 5 students in one table so that we can see the average percentage error for LM35 sensor is 0.26%. This is the bar graph for LM35 sensor, which is the compare of actual value, the blue bar, and measure value, the orange bar.
Next, result and analysis. Analysis sensor we use a SpO2 sensor. Validated device fingertip pulse oximeter. Procedure, we start to step 1. Set up the pulse oximeter and the project to do an analysis. Step 2, student 1 touch the figure in the pulse oximeter and 2 do a same time in the project at the pulse rate and SpO2 sensor. Step 3, record value pulse rate in BPM and SpO2 in oxygen percentage. Step 4, repeat the step 2 and 3 for the student 2 until student 5. Step 5, calculate the percentage error between actual value and measure for the pulse rate and SpO2. This is table for the data 5 student, which is in pulse rate in BPM. So the average we got 3.34. So this is bar chart for the pulse rate. This is table data for the 5 students of SpO2 in oxygen percentage. The percentage average is 0.6. This is bar chart for the SpO2.
The result and analysis for water sensor. We use to check the the ability of water sensor during detection. Step 1 is set up the materials and water sensor. Step 2, test water sensor by place the sensor half of full water. Step 3, record data on serial monitor for detection water result for the first experiment with water. Step 4, test the water sensor by place the sensor without any water or moist. Step 5, record the data on serial monitor for detection water result for the first experiment without water. Step 6, repeat step 2 until step 5 for second time until 5 times. The serial monitor display during detect and during not have detection. This is table that we collect from 5 times testing for water sensor. Hi, this is our final year project, which is development of health monitoring system for Coma patients via IoT. We use the power bank as a supply for this project. Coding kita compile dan dimasukkan ke dalam microcontroller yang kita guna, iaitu ESP32. So kita aktifkan dia punya sistem. LCD yang digunakan iaitu LCD 20x4. LED adalah sebagai output untuk urine detection. Dekat LCD ni, dia akan keluarkan 3 measurement dan 1 condition, iaitu body temperature, pulse rate, SpO2 and urine detection.
Dalam projek kami menggunakan 3 sensor, iaitu water sensor, temperature sensor, SpO2 sensor. SpO2 sensor ni dia mengeluarkan 2 bacaan, iaitu kita boleh tengok kat sini, pulse rate dan SpO2. Bagi temperature, dia akan mengeluarkan bacaan dalam bentuk Celsius. Okay, yang ini adalah water sensor. Fungsinya adalah untuk detect urine patient. Seterusnya kami akan buat demonstration untuk setiap sensor yang kami gunakan. Ini adalah container. Ibaratkan air ini adalah urine patient. Bila dia tidak detect air, dia akan menunjukkan di LCD display adalah not. Kalau water sensor detect tersentuh pada urine patient, LCD display akan menunjukkan yes dan LED akan menyala. Untuk temperature sensor, kita tengok dekat LCD display menunjukkan kosong kerana tiada sentuhan yang diletakkan di temperature sensor. Okey, apabila kita letakkan jari, dia akan mengeluarkan bacaan temperature di LCD display.
Kami nak tunjuk dia boleh keluar bacaan apabila coding yang dimasukkan hanya SpO2 sahaja. Okay, so bacaan dia akan dikeluarkan kat sini, nilai pulse rate dan juga nilai SpO2 nya. Dia dapat di display ke semua measurement ikut normal pulse rate dan juga SpO2.